In this screencast, we're going to work through a few examples of different aspects of steam tables to indicate how to use them. And the steam tables basically are compilations for water for both liquid and vapor phases of the specific volume, specific enthalpy, internal energy, and entropy. It also lists saturation pressure, saturation temperature. First one says determine the density of water at its critical point. So the critical point is going to be the point where the volume of the liquid and the volume of the vapor are the same. This is the highest pressure in that phase envelope. So this corresponds to 373.95 degrees C, and that volume is, we're interested in the density, which is 1 over the volume. And so 1 over this value. So I'll write 3 significant figures. So density of water at its critical point. Here we're going to calculate the quality of water at 100 degrees C. If we're given the enthalpy is 2300 kilojoules per kilogram. So by quality, what we mean is the fraction of the water that's in the vapor phase. And we're going to use the symbol Q for quality. So we're at 100 degrees C. Since it says we have quality, it means we're at saturation conditions. So saturation for water, 100 degrees C, 101 megapascals. At this condition, the enthalpy is 2300 kilojoules per kilogram. So what we want to look up is what's the enthalpy of the liquid and what's the enthalpy of the vapor at saturation conditions. We'll get those from the steam tables. And so these happen to be from a thermodynamics textbook by Elliott and Lehrer, but similar values can be found in lots of steam tables. And so the enthalpy then of the mixture of liquid and vapor is the fraction of the water that's in the vapor phase times the enthalpy in the vapor phase, and then the fraction that's in the liquid phase, which is 1 minus the fraction of vapor phase, times the enthalpy in the liquid phase. So we can substitute in numbers here, and then I can just do the math and solve for Q. In terms of significant figures, I'd say fraction that's vapor, 0.83, so 83% vapor, 17% liquid if it has this enthalpy at 100 degrees C.